and welcome to Tribe Topper. In this video session, you are going to learn about collisions and momentum conservation. Let us try to understand what we mean by a collision. So when two bodies, they come in contact for a few seconds, as you can see here, there is one ball rolling after another ball, right? So this might be at rest or this might be moving with a velocity less than the velocity of this ball. So they will collide. So this is, you can say, a situation before collision. And when they come in contact for a few seconds, that's during collision. You can add during collision, and after that they separate and the velocities have changed. That will be after collision. So this is a collision. So by collision I just mean that when two bodies, they come in contact for a few seconds and then they separate, and during a collision the velocities of the individual bodies would change. And so let's see how the momentum applies here. Like, what is law of conservation of momentum? So this is basically, we are talking for a collision only. So we say, let us say this is a ball of mass m1. This is a ball of mass m2. This has a velocity of u1 and this has a velocity of u2 initially. Now this is before collision. During collision, they collide. Obviously, so this is m1, m2, both masses. After that, they continue moving in the same direction. This is m1, this is m2, they separate, but the velocities are now v1 and v2 as the final velocities. So what will be the total momentum of this system initially? The total momentum initially would be, I'll write it as Pi, because we know P is used to denote the momentum, which is mass into velocity. So Pi is going to be m1u1, the momentum of the first ball, plus m2u2, the momentum of the second ball. This gives me the total initial momentum of the system, right? Now I'll go to total momentum finally, that is after the collision has happened. So let me write it as Pf, and that is equal to m1 v1, because the velocities have changed from u1 u2 to v1 v2. So the total final momentum of the system is m1 v1 plus m2 v2. The law of conservation of momentum of a system says that when no force is acting on it, the total momentum of the system remains conserved. Now, we can say that during the collision the force acted, but after they have separated, there is no force acting, right? So, the law of conservation of momentum says that total initial momentum Pi would be equal to the total momentum of the system after collision, right? So total initial momentum is equal to total final momentum. So this gives us a very useful equation. m1u1 plus m2u2 is equal to m1v1 plus m2v2. This is the law of conservation of momentum equation. And this is a very important equation. It helps us to find the unknown velocities. Like if we know something, what is happening before collision, then what is going to be the velocities after collision. So let's have a look at an example. So here a question says that find the velocity of a bullet of mass 5 grams which is fired from a pistol of mass 1.5 kilograms, and the recoil velocity of the pistol is 1.5 meters per second. So we say here, first of all, let's mark. Now, one thing, if you see, they have called given here the recoil velocity of the pistol. So I hope all of you know, like by action and reaction forces, or by Newton's third law, if when the bullet is fired from a gun, the bullet moves forward, but it pushes the gun backward. So you might have noticed that a person who fires the gun, his shoulder feels a jerk backward. That is because the pistol will recoil a bit, and that recoil velocity of the pistol is given to us here. Now let's convert the units here. So the mass of the bullet is given m1, 5 grams. So I'll immediately write it as 0.005 kilograms. and it is fired from a pistol of mass 1.5 grams. So M2 is 1.5 kilograms. What is U1 and U2 in this case? Because before firing, both the pistol and the bullet, they are at rest. So before firing, U1 and U2 is 0. Therefore, total initial momentum is going to be what? Total initial momentum Pi, which is M1 U1 plus M2 U2, is going to be 0 because there was no velocity earlier. Now, after firing, V1, the recoil V2 is given to us, the recoil velocity of the pistol, that is 1.5 meters per second. We have to find out V1, the velocity of the bullet. So that they want from us after firing. So after firing, what will be the total final momentum? The total final momentum is going to be PF, that is M1 V1 plus M2 V2, which is M1 is 0.005 times V1 plus the mass of the pistol is 1.5 times the velocity is also 1.5. So what are we going to do here? Just apply the law of conservation of momentum equation. So we'll say by law of conservation of momentum, M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Now this was 0 as we have already talked here. This is 0 and that is equal to M1 V1 plus M2 V2, which is 0.005 times V1 plus 1.5 into 1.5. But I'll put a negative sign here because my velocity of the bullet and the velocity of the gun, they are directed in opposite directions. So actually we should mention it here only where I've written, yeah, we can write it here that V2 is negative 1.5. So this would be 1.5 into negative 1.5. So I have minus 2.25. This gives me that 2.25, I'll take it to the other side, is equal to 0.005 times V1. Therefore, what's going to be V1? That is 2.25 divided by 0.005. And on solving, we get this as 450 meters per second. So this is the velocity of the bullet. And as you can see, we have simply applied what? The law of conservation of momentum. Before firing, our momentum was 0. After firing, the total momentum of the system is the momentum of the bullet and the momentum of the pistol. But just take care here, you will put a negative sign because the pistol, the recoil velocity of the pistol is opposite to the direction of the bullet because bullet goes forward and the pistol recoils backward. So if V1 forward is positive, V2 backward has to be negative. And simply applying that and rearranging the terms, we get the velocity of the bullet to be 450 meters per second. That's all for this video session. In the next video lesson, you are going to learn about elastic and inelastic collisions.